Okay, so 7-2, part 3, what is E? All about E and interest compounded continuously. So I have sent you multiple things to watch about E, and you should watch at least one of them all the way through so that you get a pretty good understanding of what the number E represents. E is a number, approximately 2.78. So you should check out the video to learn more about it. Okay? So up to this point, we have been working on our exponential functions that have rational bases, but now we're going to look at an irrational base. The most important irrational base is the number E. Okay, so E, I said 7.8, 2.718 approximately. Now, where does that come from? If we take this equation, y equals 1 plus 1 over x raised to the x power, and we graph it, we will get something that looks like this. And you can see this graph settles in to this line right here. This line is the equation, has an equation y equals E. And so we settle into this number. We get closer and closer to this number E. We never actually get exactly there because it's an irrational number. It goes on and on forever. Okay, so many functions use E as a base, and one of the more important ones is having to do with compound interest. So suppose we want to evaluate E. What is E to the third power? On the calculator, you have an E key, or you have an E to the X key, actually. I'm sorry, you can hit E to the X, put in 3, and you'll get this number, 20. So E to the third is approximately equal to 20. Or you can look at a graph, and then the table that goes with that graph, and find the value that goes with X equals 3. All right. Now, we looked in section 7.1 at interest compounded annually. That means you leave your money in the bank for a year, and at the end of the year, the bank gives you interest on your money. But that is not a very realistic way of getting interest. A much more common way of getting interest is continuous compounding, meaning it's unlimited compounding. So we have this formula here that looks like this. The amount that you're going to have in the bank account after a certain period of time, A of t. Okay, so this is a function A of t. Amount you'll have after a period of time is equal to P, the principal, the amount that you put in, times E raised to the power of R, which is your interest rate, times T, time in years. Okay, so here's an example. Suppose you want a contrast at the start of 5th grade that deposited $3,000 into an account that pays 5% compounded continuously. How much will you have in 4 years? So let's see how we're going to do that. So here's our values. P is the amount we start with. R is our interest rate. T is our time, 4 years. Here's our equation. So we're going to put the numbers into the equation. Looks like that. Okay, so that's pretty simple. All we have to do is put that into the calculator, and there's our answer. Okay, so at the end of 4 years, we'll have $3,664.21. And that's that. That's all we need to know about E for right now.